Hello, everyone. It looks like our attendee list is still growing pretty quickly, so we'll just give a few more minutes for everyone to log on before we get started today. If you're interested in throwing your location in the chat, it seems like we've got a lot of folks from all over the world here today, so feel free to toss your information in the chat. We'd be curious. Let's see, we've got Guam, New Zealand, Guatemala, all sorts of locations in Canada and the US. Great, thanks everyone. India. Wow. Thanks everyone, that's fun to see. Just give it 1 or 2 more minutes here. I see a question in the chat. Do we comment only on chat? So yes, due to the size of this webinar, and I'll mention this again when we get started, we have disabled the microphones and cameras for the attendees. We're expecting over 200 people to join today. So to try to keep things a little calmer, we'll have the chat and the Q&A box open as well for questions. All right, well, it's 2 minutes after the hour, so I think we'll go ahead and get started. Greetings, everyone. Thank you for joining our Diagnostic Entomology Photography webinar today. I'm Amanda Redford, the Program Coordinator for the United States Department of Agriculture Identification Technology Program, or USDA ITP. As I'm sure most of you know, the government loves our acronyms. I'll be the moderator today. Before we get started, I'd like to mention a few housekeeping items. First of all, we are recording today's event. The recording will be available on ITP's website, idtools.org, within a few days. We will also post the presenter slides on our website as well. We do welcome your questions. We will have a Q&A session at the end of the presentation, but you can submit your questions through the Q&A panel at any time during the presentation. There is also the chat box available if you would like to send a message to the panelists. Microphones and cameras have been disabled for participants due to the size of this webinar, and we are rapidly approaching 200 people in the webinar today. After today's webinar ends, you will see a survey pop up in your browser. We would very much appreciate it if you would take a few minutes to provide us some feedback on today's webinar. We are also interested in hearing which topics you'd be interested in follow-up sessions or future imaging and diagnostic identification tool webinars. That survey will also give you an opportunity to sign up on ITP's email list for digital identification product and webinar announcements. So at this point, I will hand things over to Hume Douglas to kick things off. Hume is a beetle taxonomy research scientist with Agriculture and Agri-Food Canada. Before that, he was the head of the Canadian Food Inspection Agency Insect Identification Lab. Hume?
Hello, Amanda. Just sharing my screen. Thank you very much. So I'd like to start by introducing my remaining co-presenters who are also with the Identification Technology Program, or ITP, with the United States Department of Agriculture, Animal and Plant Health Inspection Service. So they are specialists in this kind of work. Hannah Royals is an entomologist. She has worked with ITP for 8 years and works closely with port identifiers to identify intercepted pests. Paul Langlois has been with the ITP for 5 years, and he enjoys all aspects of biology and also photography. So the purpose of today's workshop is producing images for digital interactive tools. But I want to mention at the beginning, a lot of what you'll hear today is also applicable to other kinds of identification tools like dichotomous keys and fact sheets and things like that. So I'll do the section on specimen selection. Hannah Royals and Paul Langlois will talk about photography tips and tricks, camera setup and software, post-process editing. And then Amanda Redford will return to handle questions at the end and conclude the workshop. So we should begin before photography in planning the project. Once you have decided to make an identification tool, it's important to consider two factors about your finished product. These are the species that you'll be working with and the venue where you will publish the identification tool. On the species side, you will need to consider the types of images needed to illustrate the key in a way that will allow non-experts to identify specimens. This may mean transmitted light through a backlit specimen or reflected light from an opaque specimen. It will usually include some full body habitus images as well as higher magnification detail images. It can be useful to produce a representative set of images for a single species at the beginning of the project. This gives the best opportunity for planning, consultation, and ultimately completing the imaging without wasted effort or delays. It can provide confidence from the outset that the images will really help people identify the species in question. And then you need to think at this stage, will the tool allow you to identify all adult insect specimens or just males, just females, immature stages? And when planning this set of images, you'll also need to determine whether you're producing a key or identification tool only, or whether there will be accompanying species descriptions or fact sheets for each species. Usually, if you're producing a subdocument like a fact sheet for each species, you'll need a more complete set of images for each species than you would for a key alone. Okay, gotta move my notes. It is useful to include a taxonomy expert, like the ones I've included here, as a co-author of the key and collaborator, because they will be important to the development of the process at multiple steps. In imaging, at the beginning, they can help plan the images needed to illustrate the key, and they can work with you on the representative set discussed above. And then it's also important to consider the publication venue, like a journal or a website that will host the tool. Here are 4 popular ones, and there are many others. And it's useful to choose this venue early in the process. Then you can read their instructions to authors and plan the imaging to meet their specifications. So if your project is large or complicated, it can be useful to talk to the editorial team with your venue to make sure that what you have in mind is truly possible. This can help you reduce problems in publishing. And there's really a third factor to consider right at the beginning too, and that's the target audience. Will the tool be mainly used by the general public or by non-specialized biologists or specialist researchers and amateurs who already have a high level of familiarity with the general group? This choice will affect many aspects of how you design the tool, and you might wish to include a non-expert from your target audience in the design team. Active participation from a non-expert can help the team design a tool that will actually meet the needs of the target audience. So to initiate the process of developing a tool, it's very useful to plan a set of exemplar photos for one taxon, to include taxonomic experts and users in the design team, to consult the hosting venue, and consider the target audience carefully. Now I'd like to talk about selecting specimens for imaging work. Here we have some type specimens, and these are the only specimens for which we can have 100% confidence in their identification. because they're the ones on which the species concept is based. However, type specimens are not always available, and they're not always in suitable condition for photography work. Here's where a carefully considered identification by an expert is the next best way to assure the identity of specimens chosen for photography. And this means that the expert should actually recheck the diagnostic characters for that particular specimen, even if it was previously identified by an expert. This is to avoid costly errors in the production, and also to ensure that the diagnostic characters are both present and suitable for illustration on that specimen. Sometimes the expert can identify a specimen even if parts are broken, but it's good to have a specimen where the diagnostic characters really show. Interspecific variation also means that some species or specimens are closer to the species mean or average for diagnostic traits than others, and it's useful to illustrate specimens without exaggerated or reduced features. Now I'd like to talk about some characteristics of the specimen for photography. They should be clean, and they should be mounted in a somewhat standard way that shows as many diagnostic characters as possible. These kinds of simple, standardized images improve user efficiency in comparing diagnostic characters. It's useful to remember here that photographs are two-dimensional representations of three-dimensional reality. So it's more difficult to interpret a visually complex photograph than it is to interpret the same scene or specimen in real life. So this is where it helps to really have clean, standardized specimens for photography. And next, the specimens should be representative for their life stage. This is an interesting photo I found on the internet, but it has something you rarely see, and that's one of the deciduous teeth of a root weevil. And they use this tooth only for escaping the puparium, and then it's discarded early in adult life. The presence of this structure in a photograph would confuse identifiers who are looking at the 99% of specimens that no longer have this tooth. The specimen should also be clean, as I mentioned, and have as much of its cetal vestiture as possible. Here, as shown by the arrow, you can see how some setae can be rubbed off. If too many setae are lost, it can change the appearance of the insect enough to become confusing. Here, also, sometimes I've chosen to use teneral specimens or newly enclosed adult specimens for photographic reasons. In this case, the less sclerotized teneral specimens on the right have relatively more pigment in their spines than in the rest of the integument. This makes it easier to see the sculpture in the elytra. But this is just for photography. Most of the specimens that the users will see will be more darkly pigmented specimens, and it's important to save that somewhere in the key. And it's easy to see those spines in real life, just it was somewhat useful to have the teneral specimens for illustration purposes. And then finally, it's important to think of what kind of specimens users will most often examine. Will it be live, colorful specimens as shown on the left, or dried pin specimens like the one on the right? Or maybe they'll be identifying specimens mainly from trap samples and fluid, or even the dreaded sticky traps. I don't think anybody likes sticky traps. It's important to show the specimens as they're likely to appear to the target audience. So to conclude this part, it's useful to choose specimens that are intact, cleaned, and well mounted in a symmetrical way. Specimens that are not morphologically extreme and have the characters that you want to illustrate. These specimens will be relevant to the insects and the target audience will examine, or you should choose insects that are specimens that are relevant to the ones the target audience will examine. So that concludes my part of the presentation, and I'd like to pass things over to Hannah Royals for her part with imaging techniques and problem solving.
Good morning all, or evening, or whatever time it may be for you in the world. Didn't get my files shared. Right, so my name is Hannah Royals. I'm an entomologist with the Identification Technology Program here in Fort Collins, Colorado, in the US. And I'm going to be covering a couple of topics that we use, techniques and troubleshooting that we use in our lab for pinned specimen photography, as well as soft-bodied ethanol preserved specimen photography. Just as a reminder to folks who showed up a little late, this is kind of a general overview of our procedures that we follow. These aren't going to be applicable to everybody in every situation. And please use the survey at the end as an opportunity to let us know what topics you'd like to cover in more depth in future webinars, because is definitely something that we are happy to do. So here's an example of some of the photography that we are able to produce in our lab. And we are lucky enough to have a very luxurious imaging studio, a dedicated space in our lab for stacking photography. And we are able to produce very high quality, high resolution images of specimens that are just a millimeter or less, all the way up to some of the largest insects that you could think of. And we follow a standard kind of format in terms of views, like Hume mentioned. And with the quality of these photographs, you're able to actually pull out and zoom in on diagnostic characters without having to take redundant images. So what we use, I've mentioned this process called stacking, and the algorithms and software behind this stacking process can be a little bit daunting, but the idea itself is pretty simple. A specimen, generally a slide mount, or excuse me, a pin mounted specimen, is placed on a stage of some sort. And you basically tell the camera that this is the top of the specimen and here's the bottom. And what it does is takes several images from the top to the bottom with different parts of the specimen in focus. And some specimens, if they're really large or you have a really high magnification, these can take up, dozens to even hundreds of tiny slices of the specimen. And then once those images are taken, they're all imported into a software of some program. We use Zerini Stacker in our lab, and Paul will go into the options a little bit more in his section. And that software basically takes all of the in-focus parts from each of those slices and puts them together to compose a final image of your specimen with everything in focus. This, the example here, what's outlined in the dashed white line is what's in focus. Here it's the very top of the specimen on the left, and on the right, it's more of a ring further down the specimen. And this specimen actually took about 30 slices between the top and bottom. And we'll revisit this specimen here in a little bit to show you the full composite image. The one downside of this process is it can be very time consuming, but if you're taking the time to build a diagnostic tool, whether be it a key or fact sheets or website, this is definitely the way to produce the highest quality and highest resolution images that are going to be diagnostically really useful to your users. So all of this starts with a good specimen, as you mentioned, and a good specimen is a clean specimen. So I like to stress that the more you prepare and start with a good setup, clean specimen, clean image, the less you have to do post-editing. And so all of our techniques kind of follow that to be as efficient as possible and to start off in as good a situation as possible. So these pictures show kind of our setup for cleaning specimens. We use a dissecting scope on the right there with bright lights to clean and analyze our specimens before we image, make sure there's no broken pieces, and get them ready to photograph. So I'll go into a little bit more detail about our supplies, but for the big picture is, don't nitpick. This can be a really tedious process. Some specimens can be filthy. I'm sure if you've ever worked in a collection, you know the bane of Lepidoptera scales that just get everywhere. And so clean if you can, if you have the time, but if you are absolutely pressed, this might be the one step where you have a little bit of wiggle room in terms of timeliness. Try to minimize touching both the specimen and labels with your hands. Use forceps to remove labels. Oils on your hands can degrade specimens and label paper, especially if you're working with them a lot or over years. So just try to keep everything clean and tidy. And as Hugh mentioned, type material is precious. And if you are able to get your hands on it for photography, that's wonderful. But of course, always minimize interaction with type material. As he showed some damaged specimens, if they get worked on over years and years, damage is inevitable. So do whatever you can to try to limit interaction and breakage of type material. So here are kind of basic cleaning supply setups. We have a specimen stage there in the middle with gray. We've got a variety of stages in our lab. That one's my favorite. We use fine tip forceps, great for removing labels and large debris and hairs from your specimens. My favorite cleaning instrument is a paintbrush. We have a variety of them in our lab, some that have been plucked and only have a few hairs left. These are great for really gentle cleaning of debris and dust. Although sometimes you get in there with a paintbrush and all you're doing is moving the dust around. So in this case, we have this little rocket duster, which is with the red tip here, and it just puffs air very gently in a very localized area. There's a tiny hole in the top. And just be careful, make sure you look at your specimen first, make sure there aren't any really loose legs or antennae that might blow off. But once you get everything loosened up, that's a great way to do a final clean. And we also use diluted ethanol for cleaning our specimens. This is a great way to remove debris, gunk, grease. A lot of specimens regurgitate their contents when they die, and they'll have all this crusty gunk on their faces that make it really hard to view mouth parts and facial structures. So a diluted ethanol is a great way to clean those up using a paintbrush. You want to be careful not to use 100% ethanol. It dries way too quickly, and so it makes cleaning a little bit difficult. It can damage some specimens when it's that strong, and it's just really expensive. So we do use dilute, and once you clean, since it is ethanol based, it does dry really quickly once you're cleaning. So you don't ever want to use just water. You don't want moldy specimens, and you want them dry for your actual photography. And I will address this personal lubricant here hiding in the back, but we use that in our soft-bodied specimen photography for photographing in ethanol. So here's just a glimpse at our imaging setup. We use, again, this is my favorite stage on the left here. It's just a simple creation. It's wood base on the bottom. Glued over that is a piece of foam, so you have something for your specimen pin to stick into. And then a cardstock. We try to use a neutral 18% gray or something close to that, excuse me. And I will get into some of the background options and colors here in just a moment. Over that paper underneath the specimen, it's a little hard to view here, but there is a sheet of frosted acrylic. And that allows for a very, very smooth background behind your specimen, regardless of what color you are using. And that really plays into having the best image from the start. If you've got that soft, nice, even background in your original slices, that's going to minimize the amount of editing that you need to do before you import these into your tool or whatever you are using these images for. So in the middle and the right are two types of diffusers that we use most commonly in our lab. The middle is, again, that frosted acrylic sheet that we've just taped into a circle and we place around the stage with our specimen. And on the right is a modified paper lantern. So these are really cheap. It just has it has a heavy ring on the bottom to pull it down, and two Velcro straps that wrap around the camera body at the top. And when we're actually taking the photographs, this lantern will actually be around the specimen and touching the base. So it's not wailing around there above the specimen like you see here. It's just for demonstration purposes. So these are only 2 examples. We like to tell people to use their imagination when it comes to creating diffusion for their specimens, because there's a whole range of specimens. You've got really hairy ones, some are matte, some are much more shiny. So you're going to want to play around. We've had a lot of success with Kim wipes in our lab. But as long as you're careful about how they stand and that you're not going to be interfering with the specimen, use your imagination to kind of come up with these. The gentleman who created our list system for our camera setup also came up with these paper lantern ideas, and but he is now retired, but they wouldn't be that hard to recreate. So that segues really nicely into lighting. And again, this is kind of a broad coverage, but lighting is one of the more important aspects that we could ever cover. I know a lot of folks don't have the luxury of a flash system. I've seen a lot of setups where folks have just a bright table lamp focused at their specimen, which is great, but you can only go so far with that. There are a lot of different flash systems for every budget out there, and even the cheapest ones are going to outshine just a lamp pointed at your specimen. So if you do not have a flash system that talks to your camera and is synced up with your camera, with your shutter, I would look into that. It's really allows you to bump up your shutter speeds, which are going to produce the clearest, crispest images, which is also very important when you're using an image stacking software, so that each of your images is as crisp as possible. Remember, when you're setting up your specimen, that if you change your lighting at any time, you want a white balance against a neutral spot in your image. White balancing is going to be critical, again, for starting with your best images and keeping the color of your specimen as true as possible. Be careful with white backgrounds. And you can see here with this moth face is that some of the, even though the moth itself is a little dark, the background is very bright. The edges are a little bit washed out. And it's just a little hard to look at visually. If you were having to look at a screen all day long with the drastically dark specimen in a white background, it can get a little old pretty quickly. So here is that same view-pressed specimen that I showed earlier with the stacking. And I wanted to show folks why we consider it so important to photograph on a neutral background. Again, we use an 18% gray, which is considered true neutral, and Paul will get into that a little bit more in his section as well. Here's the same specimen with 4 different backgrounds. And I took these 4 images on that colored background. I did not edit them in later. I did a gray cardstock, white, blue, and a black kind of velvet stage that we have that absorbs light. And they're all great images, but you can already see that the blue one is tinged pretty blue, where it's actually more of a green, and the black one is just much darker. So if we remove those backgrounds, you can see this even more clearly. There's those same 4 images, the same specimen. The white doesn't look terrible. You know, a lot of folks use white backgrounds, but you will notice if you compare it next to the gray on the left, is that the colors are actually more muted on the white, and you lose a little bit of definition with all that white light bouncing around of the physical kind of landscape of the specimen. So, and then we have our blue and black on the bottom. And again, our blue is very whitewashed. It's reflecting that blue background a lot. And the black has just absorbed all that light. Again, you lose a lot of the definition, and your colors are just dark and muted. So this is just to highlight why we suggest a gray background. Of course, if you're publishing in a journal and they require a certain background color, you want to follow that. Though even in cases like that, we do suggest if you really want to have a certain color background, go ahead and start with gray and when you're doing your photography, and that will also be the easiest to remove in a photo editing software like Photoshop and add in a different background, be it white, black, or another color. So before I get into the ethanol photography, I wanted to cover kind of our microscope lenses. Paul will be giving you a little bit more detail on the lenses themselves and the actual setup. But I at least wanted to introduce it to show you how we photograph our tiniest specimens or the tiniest diagnostic characters. We have what's called a K2 extension tube. It's an adapter that goes onto our camera body that you can see on the far right. And it's pretty stable, but the important thing is if you ever work with this kind of setup is you have to have a very stable base to minimize vibrations. With magnification this high, you're going to see the tiniest bit of movement, footsteps. So if you're going to be using a system like this or interested in one, you need to have the setup first to create the best images. We have in our lab 5, 10, and 20x objectives that can connect to this extension tube. 20x, very rarely have I gotten there, but I've played around with some pollen grains before and gotten some fun images. So the 5x and 10x, if we need something for that small, are the ones that we use the most. The tarsi seen here on the bottom left is a little chrysomelid beetle. The beetle itself is about 3 millimeters long in total. And you can see how crisp and clear, I mean, these tiny little feet are on this specimen. And this was used, captured using the 10x objective. And this image is high enough quality that you can still actually blow it up quite larger and still maintain that quality. It is also important to remember that if you are using this as a stacking system with this magnification, sometimes these tiny specimens can actually create hundreds of slices before you can create a final image. So again, if you're looking into something, a system like this, keep in mind the amount of time that you have to invest in the project and photography as well. So just to summarize general guidelines, cleaning a specimen, great if you have the time. Check in if you are borrowing from a collection, make sure that they permit cleaning of specimens. Some request that borrowers do not clean specimens, but most generally don't have a problem with it. A stable base is critical. And I kind of put this in there in multiple senses. There's a stable physical base. So you can see here with this is our imaging lab setup in our dedicated room. We've got really big, heavy tables on cushioned floor, but also a stable base in the sense of start with a good image, a good specimen to minimize post photography editing. And Paul will talk about some of the post work, editing work that you can do in his sections. Shutter speed, keep your shutter speeds to a minimum or the minimum of 1/100th of a second. And this is where that lighting comes into play again. Those flash bulbs are going to allow you to time it to your camera, to your shutter speed, bump that up for very crisp, clear, well-lit images. And that's gonna save you time down the road in editing and produce really nice images for your project. And neutral gray background, I could stress that and talk about that all day. We highly suggest the neutral gray. You can buy cardstock cheaply at most craft stores. And there's always exceptions for white and black. I mentioned publications and certain specimens, but use your best judgment. So I'm going to just cover briefly our process for imaging alcohol specimens. These can be soft-bodied specimens. I know Thysanoptera were mentioned in the chat earlier. And so just before COVID hit, our team was working on a project for imaging buprestid larvae. And so this was a little bit of a learning curve for us. But I'll show you some of the images we were able to capture here in a couple of slides. So our basic setup is going to be very similar. We have our Petri dishes or glass beakers, some sort of container to hold glycerin, ethanol, and your specimen. Glycerin and ethanol can be expensive, so don't use a container that's ridiculously big. We use ethanol because generally these soft-bodied specimens are stored in ethanol, and we don't want to be mixing that with the water, with too much water. And we also use glycerin to help us image, and I'll give you a little bit more detail on that in a second. And glycerin happens to be soluble in ethanol, so it's an easy cleanup. And then we have specimen pins for positioning forceps and patients. This can be a tedious process if you've never photographed anything like this before. And we definitely had a steep learning curve, but it worked out well. So for a dish, we prefer something glass. It's going to be a lot easier to clean. Make sure it's not too big so you're not wasting materials. Glycerin and ethanol can be expensive. And glycerin, we prefer to use Astroglide, which is a personal lubricant. And the reason we do that over just pure glycerin, it's a little easier to find, and it's actually a little bit thicker than just a bottle of glycerin, and it does a really good job of holding your specimen. And again, it is soluble in ethanol, so make sure you're getting if you are going the route of a personal lubricant, make sure you buy a glycerin-based one and nothing fancy, no warming or anything like that, just personal lubricant. And what we're going to do with that is we start with a dollop kind of in the base of our beaker or dish. And I did rush this a little bit for the setup, so it does have a little bit of bubbles, but you don't need that much, just enough to hold the specimen up off the bottom of the dish. And then you're going to go ahead and position your specimen. So the example on the top is actually kind of a poor position. And the reason for that is you can see the specimen is very close to the edge where it's distorted by the ethanol. But essentially you're going to settle your specimen on top of the glycerin. Or if you're doing an interior view or a posterior view, you can kind of settle it in an angle, whatever you're imaging, to the top. And the glycerin does a very good job of just holding onto your specimen, and it almost looks like it's floating. Once your specimen is in position, go ahead and gently pour ethanol down the side of your vessel, whatever that might be. You don't want to disturb and get it all mixed up, because again, glycerin is soluble in ethanol. So over time, it will start to dissolve. So you want to work quickly and gently during this step. And then the bottom right here, you can see the specimen kind of looks like it's floating. It's settled there on top of the bed of glycerin with a thin layer of ethanol on top. And ethanol has a very similar, I forget the term, excuse me, diffraction gradient as water. So the light, you're going to be able to photograph through it quite easily. If you do end up with bubbles, as long as they're not going to be a major pain to remove, post editing or post photography, you can leave them, or you can easily pop them with forceps once you have the ethanol in there. So here are some examples of larvae that we were able to photograph using this method. You really can't tell that they're submerged in water. They don't really have any distortions much. You can see some debris at the bottom of the left photo of the rear end. And that's just, they had already kind of ripped apart these specimens for molecular work, so they were disintegrating a little bit. One thing I do want to also mention is, again, if you're working quickly, the major hiccup that we had with this process is we had a different flash setup last time, and the lights were very warm, and it was melting our glycerin rather quickly, and our specimen would float around. So this is another situation in which you kind of have to use your imagination with whatever setup you have and whatever works best. But that's just a kind of a brief introduction. And this would theoretically work for most soft-bodied insects. If they're heavy enough that you might not need as much glycerin, but they should be able to work for most insect groups. I would like to touch on slide photography, though we might focus on that in another session for webinar, because it's pretty straightforward. It's essentially the same process. As our stacking, we just connect our camera bodies to a dissecting scope and are able to move the plane up and down and take images. And you can take any of those images and import them into a stacking software program. But if anyone wants more details on that, please remember to put that into the survey, and we will hopefully plan some more in-depth sessions later on. So that wraps up kind of my techniques and troubleshooting guide, and I'm going to hand it over to Paul, who will get into more depth on our setup and software and image editing. Thanks.
All right, thank you, Hannah.
Mhm.
I'll go ahead and share my screen here. All right, and thank you for that introduction. So my name is Paul Langlois. I'm employed by CSU and the USDA Identification Technology Program. I'll be going over our camera setup and software that we use. We have a couple different camera bodies we utilize for certain situations, as well as different lenses for those camera bodies. I'll go over the lighting equipment, as well as other equipment and accessories we utilize, as well as the software. So our general Image ID studio setup is that we have a designated room for imaging. This helps minimize disruptions and traffic that may be walking by. It helps reduce the movement that we may see in our camera lift. We use 2 camera bodies for different situations, which I'll go into. Our camera lift is programmed to have movements based on the magnification, as well as the aperture that we'll be using to get precise overlap of those images. Our camera is also tethered to our PC with Capture One, so all of our actions and all the buttons can actually be done on the computer itself. So it really helps for fast and efficient workflow. Our 18% gray stages as used as a background, I'll go into a little bit of depth into those, as well as different diffusers that we use depending on the situation. So we use a few different cameras and lenses to cover a wide range of sizes of specimens. So here you can see in the top right, there's a fly just over 1 millimeter in size, so pretty small. We also will borrow specimens from different collections that can be quite large, such as these grasshoppers here from the University of Wyoming, large cicadas as well that we've borrowed from the Smithsonian Institution, and all sorts of sizes of beetles as well. So we need equipment that covers a wide range. One of our main cameras that we use quite often is the Canon 5DS. This is a full frame sensor camera. It's a very high megapixel camera, has 50.6 megapixels. It's capable of taking very highly detailed and high resolution images, especially when we do this focus stacking. Full frame sensor cameras generally have bigger and better pixels. You generally pay more of a premium for full frame sensor cameras, but they generally have better pixels as a rule of thumb than some small frame sensor cameras. However, small frame sensor cameras can be very useful for ultra macro, and I'll go into that for our second camera when I get to that. But the 5DS, we use this for larger specimens or anything ranging down to just a couple millimeters, depending on which lens we use. The general camera settings we use are around 1/125th of a second to 1/160th of a second. As Hannah mentioned, we don't try to go below 1/100th. The main reason here is we don't want to go over 1/250th of a second with flashes. This is common for many cameras. They have a flash speed sync limit. So the shutter speed cannot keep up with the flash if you go above 1/250th. You'll actually see the shutter in the image if you are over that shutter speed. So we keep it generally within this range of that shutter speed there. We also generally shoot in 100 ISO. Just with our lighting setup, we have good, strong, balanced light, so we don't need to bump that up any further. The lower ISO you use, generally you have less noise in your image, so you can effectively have more resolution, it appears. For the aperture setups, that we use. Certain lenses actually have somewhat of a sweet spot. So depending on what lens you have, you may find a certain aperture is more crisp than others. And if you're stacking all of your images anyways, then you'll be able to utilize the utmost sharpness that you can get. So a lot of the time I'm using f4 for a few of our lenses. That seems to be a really good sweet spot, as well as 5.6 is another really common one, f8 as well, but really any aperture. There's no set rule for these numbers, but just figure out what works best for you. Our lighting and diffusion will also be subject dependent. Depending on the specimen, it may be very glossy, it may need double diffusion or more or less intense light. So that will also vary. The lenses that we use for our 5DS, one of our main ones is this 65mm MPE macro lens. So this is an f2.8 lens that's extremely versatile. It's able to go from 1x magnification up to 5x. It's considered a macro gold standard. It's definitely a highly regarded lens in the macro world. Like I said, it's extremely versatile and also just very sharp. So it's great for highly detailed close-ups that we may need, as well as sometimes we can fit the entire specimen in there when needed as well. So a lot of the time we can accomplish all of the images that we need for one specimen, depending on the size, with this one lens. So here you can see the lens itself. It's a manual focus only lens, and you can go anywhere from 1x to 5x and anywhere in between. And here is a fly I have taken with the 5DS and this lens, and you can just see a very nice detail of all of the different hairs and all the antennae and eyes. So it's got some very good resolution. Here's an example just showing the diversity that we can capture using this lens. Here you can fit the whole body specimen right at the top left here, as well as more close-up images for the head of this fly. You can see all of the CD and get really good close-ups. If you need more magnification, you can bump it up to that 5x to get dissected genitalia images or body part images such as this antennae here. Here's an example of a photo taken by our own Lindsay C. Stone, also on our team, of a thoracic scent gland. So just a nice image I just wanted to show with you for those diagnostic purposes you may need. So for our second lens that we utilize with the 5DS is the Canon EF 100mm macro. This is another f2.8 lens. It's the L lens. It's another gold standard in the macro world. It's very crisp, highly regarded. The maximum magnification it goes to is 1:1 magnification, and it can also go up to infinity. So if you're in the field or you need more habitus style images or just more zoomed out compositions, this lens is probably going to be more suited for that. It also has autofocus motors, so it's not just a manual focus lens. Here's an example of a rhinoceros beetle taken with this 100mm macro lens. This is at 1:1 magnification, so the highest magnification for that specific lens. And you can see just the resolving power of the surface details on the pronotum there, as well as the hairs. We're able to get very sharp images, especially when we do stacking. Here are just some other large specimens taken with the 100mm macro and 5DS. So our second camera we use is a crop frame sensor camera that we have adapted a microscope tube lens on that takes microscope objectives. So the 7D Mark II is a 20 megapixel crop frame sensor camera. So a fairly high megapixel for a crop frame, but this camera is not quite outdated, but camera technology is moving so fast that everything's just getting better and better. So there are higher megapixel count crop frame cameras out there nowadays. Smaller sensor sizes, such as this crop frame, can be great for ultra macro because the pixel density on the sensor itself is generally higher. So when you start to get more magnification, you actually are able to have what appears to be more resolution. Using APS-C sensors, typical lenses also appear to project the image 1.5 times closer on those sensors, so you effectively get more magnification as well. We'll use this setup when we need anything over 5x magnification. So generally, we have 3 objectives, our 5x, 10x, and 20x objective. So this is used for smaller specimens or very close-ups of body parts, specimens generally 2 millimeters or smaller. The camera settings are, excuse me, basically the same reason for the shutter speed. We don't want to overrun that flash sync speed. We keep it at a low ISO because we have plenty of light, and the iris at the base of the tube we keep wide open, as well as lighting and diffusion will just be done as needed. So the microscope objectives that we use for this microscope camera are the Mitutoyo M-Plan APO objectives. These are especially great for photography purposes. These are Japanese glass. They're extremely good glass for photography. One reason being they have really low chromatic aberration compared to many other objectives out there. So you won't have much like purple color fringing or green fringing appearing when you have overblown light in your specimen. So they're very good for photographic purposes. One thing to note is the higher magnification you have, especially with objective lenses, the less depth of field you'll have. So in Hannah's example, where she showed the region of the specimen that's in focus, that's your depth of field. And the higher magnification you have, the less of that you'll have. So that will actually require more images in your stack to have front to back crispness in the image. So just to note, the higher magnification, the less depth of field, the more images you will need for your stack. Here's an example of 2 specimens. The one on the left is taken with the 5x Mitutoyo objective on the microscope camera. You can see all of the fine detail in the eyes and the CD, as well as on the right, we have a beagle taken with the 10x objective. Here are 2 more examples with the 5x objective on the left and the 10x on the right. Here's another one of those larvae that we had imaged within ethanol there. You can see all of the nice detail, as well as with the fly on the right down to the hairs on the antennae. So good resolution. So just a little recap of both of our camera systems and what we use for certain situations. So on the left is the 7D with the microscope objectives. These are for small specimens or very close-ups of body parts when 5x is the minimum magnification we need, or if we need to bump it up to 10 or 20x. It's an APS-C camera, so we get that high pixel density for ultra macro. And it's also firmly mounted to our microscope tube lens. So if we do need less magnification, we just easily swap camera bodies and start using the 5DS. So with the 5DS, again, we have those 2 lenses, the 65 millimeter MPE and the 100 millimeter L lens. So with those setups, with the right lens selection, we can image basically any size specimen that we would need to. And that is generally our main workhorse camera. It meets our needs 9 times out of 10 and is most often what we're using. So as Hannah stressed, and I would like to stress as well, is just the importance of light. Photography really is all about light, and having diffused and balanced light is not only pleasing to the eye, but it shows the dimension and the structure of an object very well. So having this proper light also drastically improves your camera's ability to take crisp and sharp images, so it doesn't have to kind of guess and render colors if it wasn't well exposed. So it can also help just reduce the noise if you have proper balanced light. Here on just this little triangle here, this is photography 101 and the aperture, shutter speed, and ISO. So on the bottom here we have the aperture, which is how much light you're letting in. The larger the aperture, as shown here on the left of 2.8, the more light you are letting in, and the less depth of field you'll have as well. The shutter speed is how long you are letting light in to the camera, and your ISO is the sensitivity either the film stock or the image sensor has to that light. So it's a balancing act of those three to create a proper exposure. Just really quickly, I won't go into depth about it, but it's called the inverse square law, which basically states the further away you get from your source of light, how dramatic it is, how much less light is on that surface area. So just know that as you get further and further away, the light falls off very quickly. So having your lighting position and angle can be very important. Excuse me 1 second. So for our lighting equipment that we utilize 2 Interfit S1 studio flashes. These have a very steady color temperature at 5,700 Kelvin. They stay very consistent as well, which is great. They also have AC and DC power. So we have ours plugged into the wall in the studio. If we ever needed to go off of site and bring these with, we could bring the battery power packs and utilize those. These flashes also have TTL and HSS. TTL stands for through the lens. This is effectively a way that your camera will meter the light and your flash will give an estimated output of how much flash is needed for a proper exposure. So it can kind of do the guesswork for you. In our studio setup, we don't necessarily need that, but in some situations you may. High-speed sync enables you to get around that flash speed sync limit, so you can actually use faster shutter speeds. There are some drawbacks of using high-speed sync, and if you don't need to, then there's not quite really a reason to use it. But depending on your situation, you may need that, so it's just good to keep in mind and be aware of. These flashes have a strong output of 500 watts, which we found is plenty for even our 20x magnification. One thing to note, the more magnification you have, generally the more light you need. So this has been plenty of output for us. It has a 3-second recycle time at max power. So even at max flash, it fully recycles the light ready to go for the next shot within 3 seconds. And if it's less power, it's less than that. So it's plenty fast for us to take images quickly in the stack. We use the Interfit wireless remote trigger that's put on the hot shoe of the camera, and that communicates the shutter to release the flashes. And we have 2 Manfrotto friction arms, as you can see here. These are attached to the light and clamped onto the table. And we're very easily able to move the position and angle of the light and really position them as we want to for our specimen. So we get this question a good bit with what minimal budget you may have, what do you suggest? And this really is context dependent. It matters what size of specimens you'll be imaging, what kind of quality you're looking for, but there are lots and lots of options in the macro world. So first you'll need a camera. So either a DSLR or a mirrorless camera. I would suggest around 18 megapixel minimum. These days cameras are getting better and better, and the previous year model can be had for cheaper. So just keep your eye out and do your research on what kind of camera you may be interested in. One thing about mirrorless cameras is they have actually endless lens possibilities in which you can adapt any manufacturer lens onto a mirrorless camera with the right adapter. By the way that the light is projected on the sensor. I won't go into it too much, but it's pretty amazing. So if you had, for example, a Sony mirrorless camera, you could use our Canon 5D or our Canon 65mm lens on that camera, especially being a manual focus lens camera. So anyways, I won't go into that too much, but there's a lot there. As far as your lens setup, you can use extension tubes. These are a very good budget option. It just puts space in between your lens and your camera body for more magnification, which you can see with these right here. And to the right, you can actually do a single reverse lens setup where you can actually invert the lens and you get an adapter, and this will actually produce magnification using a lens that normally would not be a macro lens. Of course, you can buy a dedicated macro lens. This is probably the best case scenario, or a tube lens like we have for our microscope camera with microscope objectives, depending how much magnification you need. That may be the route you want to go. As far as lights, I'd say 2-speed lights and a trigger is probably your cheapest option. There are also light boxes to have continuous light. You are a little bit more limited there. You can't really control the angle and intensity on certain sides as you may need, like you can with other flash setups, but that is an option. Also a macro rail, either a manual movement or a programmed macro rail, so you can get precise movements for your stacks. You can do it by hand and just move it a couple millimeters by yourself, as you can see here with this manual macro rail, or Stack Shot, and some other companies make automatic programmed rails that can also be done. You'll also need your stacking software or Photoshop to stack those images to create your final composite. So just going to touch on this real quick. Diffusing light, like I mentioned, it's really important for the structure and architecture of what you're imaging. There's 2 types of diffusion, which is transmission diffusion, where light is passing through an object. And there's also reflection when you're bouncing that light off of something, such as a wall or an umbrella or a reflector. But as far as transmission, that's generally what we're using. The paper lantern, as Hannah mentioned, is great. Vellum paper is kind of a frosted type paper that diffuses really nicely. I prefer vellum paper with a few Kim wipes on there. It kind of does some extra diffusion, and it just works really well. So in choosing your background, like we mentioned, we really do enjoy 18% gray or just a neutral gray. What's great about 18% gray in the photography world is it's actually when your camera takes an exposure and you have a well-balanced histogram, just a proper exposure, the average of all that light is actually shooting for around 18% gray. That's what your camera is trying to do. So it's just good in that regard. It's good for exposing. It's easy to get a good white balance. It generally works really great. All the colors pop as they should. It's also really easy on the eyes. It's a professional style for documenting these specimens. And for some instances, it's just the best kind of jack of all trades kind of background. In some of the fly examples I've shown you, they had very dark black CV. So if I were to use a black background, those would kind of wash out or not be as seen as easily. Whereas on white or gray background, it would work great. But the inverse is also true. If it's a very white, hairy specimen, you would rather use a black background or gray. But with gray, we can kind of cover all of our bases, and it just really works well. So as far as the software we use Capture One as our image processing software. The biggest benefit of this is we can have our camera hooked up to our computer and use Capture One basically as our controller. We can take the shutter, we can change the aperture, the shutter speed, everything in Capture One with our mouse on our computer. We can also, with this live tethering, we can see the live view on our computer screen. So it just works exceptionally well. For our camera lift, it's currently discontinued from the man who built it has retired, but there are many options online. He was not the only one making a setup like this, but that can be found in different areas of the internet. We also use Zerini Stacker for our stacking software. Helicon is another great option, very comparable. Photoshop can also be used, but we use Zerini. And then for Photoshop, we do our final edits and sizing in Photoshop. So just want to touch on this a little bit, imaging with dissecting or compound scopes versus SLR cameras. So some of the benefits are it's common equipment among many labs. They have very high magnification capabilities, and stacking images can still be done. Some of the cons, however, are you cannot manage and control your light as much as you can with studio photography, and light diffusion can still be done. Oftentimes it can be a little more difficult, and you can't really get that control like you can with some flash setups. And the structure as well, since you can't really control the angles as much, or the intensity on certain sides, you can't get that structure like you can a lot of the time with flash setups. Also, microscope cameras, generally as a rule of thumb, are not very high resolution. They don't have very high of a pixel count, and they have smaller sensors. So, but many microscopes have the option to set up a DSLR camera on top, as you can see in this image here. So in that case, you are having a larger sensor and a just more megapixel sensor. So that may be a better option. But when you're getting into very high macro, that pixel density does matter. So sometimes more megapixels does not mean better for microscope purposes. Okay, and that's it for our equipment section. I'll just jump into a little bit of our post-process editing, processing your images for stacking, shooting in RAW or JPEG, as well as stacking those images and retouching, the final touch-ups in Photoshop, as well as file sizes and optimization of your files. So in processing your images, we use Capture One, as I've mentioned, but what you'll be doing is you'll export your images from your software to send over for stacking. But you'll want to think about what file you shot in or what you will be shooting in. You shoot in RAW or JPEG. In photography, a camera is generally able to shoot in those two types, either RAW or JPEG. A RAW file is all of the data and wavelengths that your sensor picks up. It doesn't compress all of that. It has all of that data in the file. So it is a much larger file than a JPEG. When your camera shoots in JPEG, it takes that data and it interprets it and compresses it into a smaller file that's slightly edited to get the highlights and shadows right. So that is what your camera is doing for RAW versus JPEG. But you'll want to think about, is it even worth shooting RAW? Do you need to? We actually do not shoot in RAW. We have a great lighting setup, and the color science with Canon is really great, so we don't really have to edit colors all that much. Just really little tweaks in Photoshop, really nothing of changing any colors by any means. So you'll want to consider if RAW is even worth it in your situation, how much time you want to spend editing your images. We shoot in extra fine JPEG in our camera, and then they're sent into Capture One, and then they're saved as TIFFs. And then we send those TIFFs over for stacking. And most importantly, especially when shooting JPEG, is you want to get your lighting and exposure right the first time, because that data is kind of cooked into the file of the JPEG file, whereas RAW files can be much more easily manipulated. So for post-processing, stacking and retouching those images. So like Hannah mentioned, you want to select the top of the specimen to the bottom of the specimen. If you're only doing the head, you may want the tips of the antennae to the base of the pronotum or whatever you're imaging. Just you'll select all of those files that have focus to send over for stacking. You want to make sure the white balance is the same for all of those. If you set your camera ahead of time to a specific white balance, then they should all be the same. If you used auto white balance of any sort, it can change slightly. So you may want to sync those up in Capture One or Lightroom before you export them out. So then you'll export those, you'll put those into Zerini and you'll stack them. And then you'll need to do some retouching more than likely. But Zerini is able to create smaller stacks, and you can just create a stack of one of the antennae, for example, or just part of the eye. So if you have any odd overlapping, you can fix those. Zerini also, you're able to touch from individual frames, which is great. And also the retouching brush can selectively retouch dark or lighter tones, not just all of that data that's there. So you can help match your layers really nicely. Here's an example of the translucent foreground effect that happens in Zerini. When you're taking images in slices like this and everything's in focus, Zerini will try to interpret that image, and sometimes it just gets it a little wrong. So here, the antennae behind this femur here is trying to also be shown. So you'll need to fix that. So you'll create a small stack of this leg and femur, and then you'll touch up in Zerini to get rid of that translucent effect to get a full looking leg. So after you have your stacked image, that is all of those files compressed back all into one, everything's in focus, you will bring that into Photoshop to just clean up and make it look a little better or change the sizes up. So we often use the clone and heal tool to remove dust and streaks. It's very common to have little specks of dust on your sensor. And when you stack images, those dust will turn into a streak because they'll connect. So we'll come into Photoshop and use this healing tool right here on the left sidebar, or down here is the cloning tool. And we'll find these dust streaks and get rid of them. So if you invert your color, this is just a little tip I use, Control I in Photoshop just quickly inverts your color. You're able to quickly get rid of these dust streaks and then revert back to your normal color. Just an easy way to track them all down. We'll also change the levels a little bit by adjusting the tonal range, the midtones, blacks, and highlights. That just helps the colors pop, or just how it should look. As well as we'll do some sharpening and sizing. So I prefer to use unsharp mask. There are several sharpening tools in Photoshop. Some of them can kind of over process or over sharpen the image. In my opinion, unsharp mask is just a very nice subtle sharpening. So that's generally the option I'm using. As well as sizing our image, we generally like to make sure at 100% view that the image is sharp. So if we see that it's still a little blurry at 100%, we might size it down just a little bit until it's nice and crisp. In Photoshop, you can also do custom resolutions and sizes, and you can actually save your own presets. So if there's a certain size you're always wanting to use, you can save that and just keep reusing that recipe. So a little bit on resolution and dimensions, pixels versus file size and megabytes. So this may seem a little obvious, but the more pixels per amount of area, the higher resolution that image is. So pixel density is resolution, really. So reducing the image size in pixels will make that image size at full scale actually smaller in print and in monitors. So that's something to be aware of. But as far as file size, for example, this image right here is 8.7 megabytes. The larger the file size, the more space is going to be needed for storage. So in reducing that image file size, it can reduce the storage space, but can also lower the details and sharpness that you see. And especially when it's blown up, like large prints or screens, you effectively lose resolution. Okay, and here's my last slide, just a little bit about the optimization of your files for file types and size considerations. So our stacked TIFFs that come out of Zerini will touch up those dust streaks and specks, and then we'll save that. And that is our final and original, what we call is our original TIFFs. So those are never sized down ever more. They're kind of just our backups as the highest quality for storage that we can have. So we'll save JPEGs from new copies of that and create backups of that, but we'll always keep our TIFFs, and we always suggest you always keep your original images. You'll want to consider if your images are designated for the web, and consider the dimensions of it and the megabyte size. So I like giving this example for Facebook. A lot of the time you'll hear people will upload an image and say the Facebook compressed it and kind of destroyed the quality, so to speak. One way you can help avoid that is see what the actual file dimensions that Facebook uses, and you can set your dimensions to be that. So when you upload it, they don't really compress or size down your image for you. You kind of did it yourself ahead of time. So you'll want to consider your dimensions for compression purposes. If this is also for a web page, you may want to think about megabyte size for how quickly that image will load. So especially in areas where people have much slower internet connections, this can be exceptionally a big issue for them. So you'll want to make sure that they're able to load that image well, while also balancing for the resolution that you still want. If this is for publication or an online database, you may want full-size images, depending on what the journal requires, of course, and whatever file they want. So if they want a PNG or a TIFF, for example, we suggest always making those copies from that original image. Don't have your multiple JPEGs that have been sized down and then return that into a PNG or JPEG. It's good to always do it from the original for the best quality. Also, naming your files. We find this incredibly important as well. We like to have adequate information in our files, but we like to keep it a little short if possible, but just so there's adequate information. You can have issues with transferring the files if they're extremely long. Here's just an example of this beetle here to the left. We have the genus, species name, the institution it came from, so the Smithsonian Institution. This is a holotype specimen. So the original, we'll mark that in the file name. The photographer's initials, myself, Paul Langlois, as well as this is a lateral with scale. So this one's kind of on the longer side, especially because the genus species name, but it has all the information we generally try to include. We also like to avoid punctuation in file names. This isn't always an issue, but some web pages do have issues with punctuation in image files. So that is something to be aware of. So with that, that is all I have to share with you. I know we all want to thank you very much for coming. And with that, I think we'll jump into our Q&A.
Yes, thank you, Paul. So we have a good number of questions here in the Q&A. If you have a question that you have not yet submitted, please make sure to submit that into the Q&A box, and we will get to as many questions as we can. So we have a couple of questions about the 18% gray backgrounds. Hannah, can you give us a little bit more detail about where you guys get that cardstock that has the smooth appearance to it rather than like a modeled appearance?
So I saw a couple comments or in questions about the cardstock. One, you can get this from pretty much any art store, Office Depot. Most of them will have something that's close enough. It does not have to be exactly 18% gray. That's just what we use for our photography, but anything close is going to be just fine. There was a comment or question about how we kind of get it nice and blurred because yes, cardstock has fibers or they might not be uniform gray. And that's why we use that vellum or that frosted acrylic over that because otherwise you're going to spend a lot of time editing that in Photoshop. So if you have something that you can put over, keeps it smooth and it makes it really easy.
I'll add to that real quick. You can also find them on a lot of photography equipment pages, B&H Photo, Adorama.
And they will have a smooth cardstock as well.
Yeah, correct.
Thank you. We also have a couple questions about stacking and if there's recommended guidelines for how many layers or how you calculate the steps.
Yep. So I'll start this off. Paul will probably have a little bit more to add. The system that we use is fairly automated. So when we tell the camera system, okay, here's the top of the specimen, here's the bottom, it self-calculates how far it needs to move for each one and calculates the final number of layers. We don't tell that system how many to take. I know some of the stack shots are a little bit more manual and you have to set the step size. So it's just going to be dependent on step size, magnification, and how large your specimen is. So it's pretty variable.
Thank you. Paul, did you have anything to add to that?
Not quite. I'll just say that the number of slices isn't always a set number. It does matter on the size of the specimen and magnification. Yeah.
Okay. Let's see. I think we can go now. There's a number of questions about the glycerin and the lubricant. So there's one question about can tiny specimens be completely subsumed in the glycerin lubricant to orient them in particular positions, or will that distort the images?
Yep. So this question's from Zach. Thank you. Yes, but I would be hesitant to do so. Most tiny specimens are going to be fragile, and that lube, since it is pretty stiff, that lubricant glycerin, you're going to have a hard time cleaning it off, and that's what I would worry about. We did have a comment earlier in the chat to panelists that a good alternative to glycerin is hand sanitizer. We have not tried that, so I can't attest to that, but to me it would make sense that would be a little bit easier to manipulate small specimens in. So it's going to be thinner and easier to clean off. So I would definitely recommend trying that.
And do we have any tips to offer for dissected or cleared genitalia in glycerin?
Yep. So this was a question from an anonymous attendee. Yes, for cleared genitalia. So I worked with genitalia and slide images extensively for my thesis. I recommend doing those on a temporary slide mount and taking a stack instead of trying to put them into glycerin, because those tiny clear genitalia are just going to float around even in glycerin. But you can create temporary slides to image those most easily. For some other specimens, we generally use pins to hold them in the glycerin and just slide a pin underneath them to hold them up if we need to, and you can edit that out in Photoshop.
So let's see. Oh, I was just gonna. Sorry, there's lots of questions popping up here and there's one or two disappearing. So let's see. Can you clarify what type of microscope objectives can be used simply on a tube? I know some of them will not work without attaching to another camera lens. This might be a question for Paul.
Let's see here. Can you repeat the question?
Can you clarify what type of microscope objectives can be used simply on a tube? I know some of them will not work without attaching to another camera lens.
Yeah, so for our instance on our microscope camera, it has the Canon lens mount on one end, and then it's the tube, and then it has a microscope thread adapter on the other end. So whatever camera body you're using, you'll need the tube to have the lens mount for that camera, and then whatever, I believe it's a common thread pitch for the microscope objectives. If you look up tube lens or microscope camera tube lens, you can find some more of that information depending on what manufacturer you use.
Thank you, Paul. Okay, sort of a, well, we kind of answered this question in the presentation, but for your microscope lens rail system, how do you deal with vibrations? Has that been an issue in the past? That is something that we have dealt with and tried to troubleshoot. So
Yep.
it looks like Hannah would like to take this one.
So yep, vibrations are always going to be an issue. I mentioned kind of at the beginning and end that a stable base is your best friend. We have a closed off imaging studio that is separate from the rest of our lab with very, very heavy tables, and the rail system has a heavy base itself. And when we're using particularly the microscope objectives, we basically keep as still as we can. We try to keep the fans off and the AC minimized in that room. But a heavy stable table base is going to, and making sure that rail system is bolted down is going to be your best bet.
Great, thank you. There's another question. This one says, with regards to cleaning specimens, do you have any advice on cleaning verdigris caused by old copper pins?
Yep. So verdigris, you're going to come across this in every collection. If you don't know, it's that green mineral that comes up on particularly copper, old copper pins, and it's usually caused by grease coming out of a specimen. In our lab, what we've done is basically just carefully, you can get 99% of it off with a paintbrush. And if you can break it up, it's a very fragile growth, and you can break it up and use the little duster to blow the rest off. If you follow up with a little bit of ethanol, as long as it, you don't have a really, if you have a really scaly specimen like a LEPS, I would avoid ethanol just for the sake of not clearing off too many scales. But for a lot of beetle specimens in particular, going after it, so brush first, dust it off, and then use your ethanol to clean up a little bit, and that'll help also clean up some of the grease that's coming from that specimen and causing that in the first place.
Great, thank you. Quick question about stacking. Does it make a difference if you stack top down or bottom up?
Paul might want to answer this one. I'll put in my 2 cents. Generally, from what we've experienced, it doesn't matter. There have been situations with particularly kind of triangular specimens, some beetles, that if we find something goofy with that final stacked image, we'll switch it and we'll turn it around. But in general, we've tried it both ways several times with different specimens, and it hasn't made much of a difference. Especially one more point there, Zerini has a nice way to edit your images, as Paul mentioned. If you do have kind of that ghosting see-through effect, that is easier than restacking it one way or the other.
Yeah, I found it hasn't really mattered. The only reason I I set the bottom first and then I set the top, because then the camera's already at the top and then it goes top to bottom. So it kind of just minimizes movement needed on the lift.
Great. So we just had a follow-up comment on the hand sanitizer. One attendee has found that hand sanitizer sometimes affects photos because the surface is evaporating too fast. That's a helpful tip. Let's see, we probably only have time for 1 or 2 more questions. So here's a good one. What kind of lighting setup do you use to establish your preview or remote viewing before taking pictures with the flash?
So
With our setup, we have it tethered to our computer. So Capture One, our imaging processing software, it has this live view feature. Lightroom doesn't have this, and that's one big reason we use that. So we're able to see what our camera is seeing in Capture One, as well as changing our camera settings there. I see two that I'd like to address as well real quick. One is about our image scale bars. These were actually given to us by the same guy who had retired, but I'm sure online people have, or the community, done stuff like this. And what those are is it bases the scale bar based on the camera you're using because of the megapixel count. It has a certain size for those megapixels. So it bases your scale on that. So I would just do a good little bit of Googling maybe for what camera body you're using and what magnification, and you may be able to find that information.
And just to explain that a little further, it's a simple, again, like you said, it's custom to our camera setup, and it's a text file that's imported into Photoshop. So it's specific to our camera setup, but we put those in Photoshop. And yep.
Well, in order to respect everyone's time, I'm afraid that is all the time that we have for questions today. So there's still quite a few really great questions remaining in the Q&A that I'm sorry that we were not able to get to. We will try to answer those and post the answers on our website, but also those are potentially great opportunities for follow-up sessions. So as we have mentioned a couple of times at the end of this webinar, you'll see a survey pop up. If you'd like us to cover any of these topics in a follow-up session, just let us know in that survey and we would be happy to. So I'd like to once again thank our three presenters, Hume, Hannah, and Paul, for sharing all of this great information today. Please do fill out that survey. That survey will also offer you the opportunity to be added to ITP's mailing list, where we send out product and event announcements. Many of you learned about this event through that mailing list. We are also interested in hearing what topics you would like to see covered in future webinars of this type. So whether it's about imaging specifically or about digital identification tools in general. So, and also, as I mentioned at the beginning, a recording of this session, along with the presenter slides, will be available on the ITP website, idtools.org, within a few days. So it will take us just a bit to get that up, but we will get it up. Thanks again for taking the time out of your busy schedules to attend today. We look forward to hearing from you. Have a wonderful rest of your day.
Thanks, everyone.
Thank you all. Thank you all.